Deep learning laptop. Sounds like an oxymoron to me. So when Lambda reached out to me, excited to share with me their latest Tensorbook, a laptop for doing deep learning, I was pretty curious to check it out. This latest version Tensorbook is essentially a maxed out Razer Blade laptop. And these Razer Blade laptops tend to be geared more so to gamers, but as is often the case, especially with entry-level deep learning machines, the specs between a gaming machine and a deep learning machine can often be very similar, if not identical. Lambda also sent me their previous model Tensorbook, which has the same specs but a different chassis. So I'll be comparing to that as well as previous laptops that I've personally owned over the years, laptops I can find online, and my current laptop, the MacBook Pro. Inside the laptop, we have an 80 watt-hour battery, two 1 terabyte NVMe drives for storage, 64 gigabytes of RAM, which is pretty hefty for a laptop. The CPU is an 8-core Intel i7-11800H, and the GPU, the crown jewel of the laptop, is a 3080 Max Q. Now, if you're like me, you have no idea what a Max Q is, and what does that mean? How does this thing actually perform compared to desktop GPUs that we're familiar with? I've run my own deep learning benchmark here. It's the same one that I've used to test other desktop GPUs and workstations and all that. It's essentially a training and fitment task. So in this chart, smaller is better. It indicates a faster processing time for that training. So the 3080 Max Q GPU is 12% faster than a 1080 Ti in a desktop build. It also has 16 gigabytes of memory versus the 11 in the 1080 Ti. Now, you might be wondering though, wait a second, why are we comparing this to a 1080 Ti? This is a 3080. Shouldn't we be comparing it to a 3090 or a 3070? And this is where the strange NVIDIA nomenclature enters the chat, and it can get kind of confusing. But these laptop GPUs, this laptop 3080 Max Q, is not comparable to a desktop 3080. Furthermore, it gets even more absurd when you compare this to something like the A6000. There are laptops with an A6000 in them, but that A6000 it has 16 gigabytes of memory versus the desktop A6000, which has 48 gigabytes of GPU memory. Also, that A6000 is an incredible GPU, extremely powerful GPU. The laptop version, again, A6000 laptop version, is 16 gigabytes of memory, and at least from everything that I can find, and then also I was asking the people at Lambda, hey, why don't you guys do the A6000? And they're the ones that were like, well, actually, the A6000, let me tell you, it seems like it's the same chip or very, very similar chip, so it's not actually any significant performance increase over the 3080 Max Q, and then also it's the same amount of memory. It's basically the same chip. It's really weird what they're doing there. I feel like nobody in their right mind would buy one of these A6000 laptops if they fully understood. Like, the only reason you would buy an A6000 laptop, in my humble opinion, is you have been misled. And I don't know that it's your fault. So with that in mind, the 3080 Max Q is essentially the best laptop GPU that money can buy right now. You might be able to actually get a little more performance if you do get one of those A6000 laptop GPUs. I would really love to test one and really see, because it seems like, in my opinion, it just seems like people are confused about what actually is that GPU, and it seems to be priced like it's an A6000 in a laptop, but it is simply, from what I can tell, not. Next, let's talk thermals. First, by comparing this Razer Blade laptop to a more generic laptop, and I'm going to actually compare first to the previous model Tensorbook, because I think that's the fairest way. These are both very high performance laptops, but one's the actual Razer Blade laptop, which has these things like the vapor chamber and all that, versus a more traditional-ish laptop like the previous model Tensorbook, but still very high performance. Interestingly enough here, the latest Tensorbook, the one that is essentially a Razer Blade laptop, it actually runs a smidgen hotter than the previous model Tensorbook. This is also unsurprisingly true if we look specifically at the GPU itself. Now, these temperature differences are slight enough to, if we just look a little deeper, be explained, I think, entirely by the wattages. So the GPU in the latest Tensorbook is just simply capable of maxing out that full 80 watts, whereas the previous one just wasn't getting that full 80 watts. And I think that's really all it takes to equal this delta in temperatures. Performance-wise, we can see the latest version Tensorbook does run a little bit faster in performance. And this is, again, probably completely described by the fact that the GPU is just simply being allowed to pull its full wattage. So in my research, there was much ado made marketing-wise about the vapor chamber in the Razer Blade laptop. And while I think it is very tough to cool all of these components such that you could run them all at full tilt for hours on end, I don't know that the vapor chamber is necessarily any better than other just simple air cooling and heatsink type technologies that have existed in laptops for a while. So it's not bad. The cooling is not bad. It's just not a major breakthrough. So since this is a laptop, we can also compare powered, i.e. plugged in performance to battery only performance. So when this machine is on battery power only, we see a 24% drop in at least GPU training performance on this benchmark. And with that comes lower wattages, and with that comes lower temperatures. But essentially a 24% performance hit when you're just on battery. If you're curious, the battery life, not plugged in, running at full 100%, keep in mind the battery pack itself is an 80 watt hour battery. And the GPU alone wants to take in 80 watts. It doesn't when it's on battery only, but then when you combine everything else that's going on, it adds up to, you might be able to guess, about 80 watts. And this battery does indeed last about an hour, not plugged in, but yet still running this benchmark. In regular, everyday use, I found this laptop battery to be lasting me anywhere from 5 to 6 hours, but this is going to vary hugely depending on what you're doing, how many tabs you have open in your browser, and so on. So now onto the I/O of the laptop. We'll actually start with the screen itself. It's a 15-inch 1440p 165 hertz display, and I really like it. It's a nice anti-reflective display. It looks great in various lighting conditions. I think this is probably the thing that is kind of more overboardy for a data science laptop, but we get it because the chassis is, again, a gaming laptop, so it's a little more important in that gaming laptop sector than for this, but no reason we can't enjoy a nice screen. The keyboard is a TKL style keyboard, and I think the thing I like the most about it is the spacing of the keys. They're not all like bunched in. They didn't try to stuff as many keys as possible. There's no number pad stuffed in on there, and I really like that. You know, with a deep learning or a data science laptop, you'd probably see that number pad, and I know lots of people like the number pad, but even when I had a number pad on my keyboard, I never used it, and I have been using a TKL style keyboard for years now, and I really like that, and I like the spacing. It's a comfortable laptop keyboard to actually use, but then also to go back and forth between a desktop and a laptop. I often find I have to get used to like squishing up my fingers so I can use those keyboards, whereas here it's just natural. It doesn't feel any different than the spacing of any other keyboard that I have. So I really am definitely a big fan of this keyboard, but keyboards are always super polarizing. So I would suggest that you maybe go try like one of the Razer Blade laptops somewhere if you have the ability to, and see if you like that keyboard or not. Next up, a thing that is often seemingly an afterthought for laptop manufacturers, that is the touchpad. So historically, if I went somewhere with my laptop and I forgot my mouse, it was a sinking feeling in the chest. It was just terrible. You know, there was at least more than one occasion where I had to go buy a wireless mouse when I was traveling because I simply forgot mine when I was packing. Ever since I've owned MacBooks, however, I've learned that no, a touchpad, when done well, and if it's large enough, a touchpad is actually really nice. Like, you can fully function on a laptop with just a touchpad. And I'm pleased to say the Razer Blade laptops actually come with a pretty good sized touchpad. It's got a lot of good software to it. I'm actually really pleased with this, and it's kind of surprising. Again, this is meant to be a gaming laptop, so the fact that the touchpad wasn't an afterthought is surprising, honestly. But I really appreciate that. So in that way, I think that is one way that this, Razer Blade, just in general laptop, kind of begins to be more of a plausible generic laptop and just a nice laptop to have for other things besides gaming or data science and all that. So I really like it. It has a lot of the software that you would expect, like a double tap for a right click, or just like a tap and drag for click and drag. You can tap to click or a long press and click. All that kind of stuff that you kind of probably expect in a touchpad if you use them. It does function. The only complaint I have is if you want to press to click, the higher up on that touchpad you get on that Razer Blade laptop, the harder the press gets, to the point where it's actually pretty hard to press. And I wish that was different, at least on the MacBook. That is not that way. I don't know the engineering that would be required to accomplish that. But just keep that in mind. That's probably my only complaint. You can still tap to click anywhere on there, and it's all the same. It just kind of depends what your habit. And I'm personally in the habit to actually, press to click rather than to tap to click. But anyways, at the end of the day, that's kind of like my main qualm and quibble, I guess, with the chassis. Is just I wish that was different, but everything else is so great that if that's the only problem, I'm actually pretty happy with that. Next up, the ports. That first port is the power port, and you might be thinking, why are we using that over the USB-C/Thunderbolt ports? So also on this laptop, you do have two USB-C/Thunderbolt ports, and you can still power the laptop over those ports. The problem is it's not enough power. So this laptop at full load will still lose power if you're only powering over USB-C/Thunderbolt. The reason for that is if you have one of these chargers, it's still only going to output 100 to 140 watts, whereas this brick essentially powers this laptop at 230 watts. So that's the difference, and that's why you have this special kind of proprietary looking port. Besides that port and the two aforementioned USB-C/Thunderbolt ports, we also have three USB 3.2 ports. There's a full-size HDMI, a headphone/microphone combo jack, and then also a full-size SD card reader. I think overall for the ports, that's like a 9.5 out of 10 for me. The only thing I wish we still had here is an actual Ethernet port. I know you can do like a converter or something like that, but I just wish you had a standard one right here on the laptop. We didn't have to think about it. Similar to why I still like to have SD card readers. I still use those, so I like to have them, but I think eventually those will be phased out. But I think even for like a gaming laptop, I think you still to this day would prefer to be hardwired over using Wi-Fi. So I feel like even as the gaming laptop, I think that's probably the only change I wish there was. Just have like an actual port there. You have the space for it. Just do it. That would be my only change. This laptop also does have laptop speakers, and they sound like laptop speakers. For fit and finish, I give it like a 8.5 out of 10. I think it's a really good laptop. It is a premium feeling laptop, but it should be at the price tag that it is, which is $3,500. This puts you in the realm of MacBooks, and that's what I'm going to compare it to, especially for fit and finish at this price. And for me, a MacBook is still kind of the pinnacle of fit and finish and just feeling like a very well-built machine that I expect to last me a long time. That said, MacBooks have had their problems over the years, and there's no reason to believe necessarily that won't continue to be the case or won't sometimes be the case for MacBooks, or that this Lambda /Razer Tensorbook thing, it could be a really great laptop. It could last you for 10 years, or it could not. We really don't know. One thing that we do know is that the Razer Blade laptops have historically had battery problems. Now, this has been addressed, I believe, multiple times, and we will just have to, it remains to be seen whether or not this will actually be resolved this time around. The problem they've had is just battery bloat. And I think the reason for that is pretty simple. These are high-performance laptops. They're going to have high power draw and need to have high power back into the laptop and so on. Again, like I said, I mean, it's not quite I guess on average, it's probably double the power input required to those batteries, and then the output for that battery also is probably double. So just the life of a battery for a laptop like this is a hard life. so so I think that's probably why you have these battery problems with these laptops. Also, I will say getting to the battery and like replacing that battery is not super difficult. But if you had battery bloat and then maybe that damaged something else in the laptop, then you got to go through customer service, and that can be quite the headache, especially through Razer. If anything, if I was going to buy a Razer Blade laptop anyways, I might just buy the Tensorbook just so I can deal with Lambda instead of dealing with Razer. So who is this laptop for? The price is $3,500. That puts it squarely in the range of M1 MacBook territory. The M1 chip itself is a better CPU than the CPU that's in this machine. For the M1 Mac, if you want to get 64 gigs of RAM, you're going to have to pay like I think an extra $400 for that extra 32 gigs. And then I'm trying to think for storage. I can't remember off the top of my head what the extra storage will be, but I guarantee it's not coming with 2 terabytes at that $3,500 price point. So spec-wise, this laptop is better than an M1 Mac except for the CPU. But one thing it does that the M1 Mac just simply cannot do or do well is deep learning. Now, there is marketing that says you can do deep learning on the M1 Mac, and it's great and all that, but you can do deep learning on a Raspberry Pi. That doesn't mean you want to, right? And the same thing is true here. So if you're trying to dev deep learning models, and that's something that you're frequently doing, or not even deep learning, just anything that's GPU accelerated. There's a lot of data science now that is GPU acceleratable. And if you're trying to do any of that, this is a laptop that you might be interested in. But then you still also have to ask yourself, well, do you need this laptop, or do you maybe want to just get a $100 Chromebook and then shell into a web server that you're paying far less money for, probably over a period of time? So generally the number I usually go with is about 2 to 3 months. If you're training something for 2 to 3 months, 24/7 on some cloud server, it starts to have made sense that you maybe should have bought the resources and used them locally. But it depends. And right now we are in like a crazy GPU boom where GPU prices in the cloud have like halved or even like thirded. I don't know what to call that, but they've become so cheap. So even from Lambda themselves, you can rent an A100, the craziest GPU in the world. You can rent that for $1.10 an hour. So, well, $3,500 or $3,400 with your Chromebook will go a really long way. So you have to think, like, do I actually need a laptop? Or can I just or do I need the laptop to be able to local compute this? Or could I theoretically do this just connecting into the cloud? And I think that for a lot of people, you probably can just connect to the cloud, and that's totally fine. But if you're someone who is traveling a lot, or maybe you don't want to connect to the Wi-Fi, if you're on the plane, a boat, car, often, depending on where you're traveling, there's lots of reasons why being able to compute locally on that laptop will become very important to you. And only you know if that's of importance to you, right? So at least for me, if I'm on a plane, I would wish on nobody to shell on, over a plane's Wi-Fi. It's the worst. So I get that. Or maybe you want to do R&D and you're trying to do deep learning with a game, for example, something with some sort of GUI. In this case, you would still likely want to be local. There's lots of ways that you could get around this, but it's more tedious and annoying. And then finally, I actually kind of think this is a really good entry-level deep learning machine, because you are going to outgrow your first deep learning machine almost no matter what, unless you just quit deep learning. And so in this way, when you outgrow this as your main machine, you'll be left with a really capable laptop, right? And I don't think you'll regret it. Like I've really enjoyed having this. I've had this for a few months now, and when I go out the door, I'm not grabbing my MacBook anymore. I'm taking the Tensorbook because it's way more versatile for my needs. And I've really enjoyed having that power, and I'm still, especially if you're used to working in Linux, it's nice to just you're in that environment. Mac OS is really close to that, but it's not the same. So if you're just trying to get into deep learning and you're looking for an entry level deep learning machine, I think this is it. I mean, generally my number is about 10 gigs of GPU memory is enough to like get started. You're not going to be training GPT-3 or anything like that. But I would go so far as to say, like, I don't know, 80+% of all the deep learning will work on this laptop. So I think that in that way, it's just a great entry level machine. And it's really versatile. It's just like, it's a great entry level machine for a pretty good price. And the cherry on top is that it happens to be a laptop, right? So for those reasons, I mean, there could be other reasons. It's really kind of like, it's up to you. If you really want a laptop, I think this is a really good one to look at. It doesn't look like they're marking anything up. And compared to other like deep learning capable, we'll say, laptops on the market, this is priced really competitively. I would encourage anybody, if you think you know of a place where you can get a better price for this kind of performance, post it in the comments below, because I looked around. This is really well priced. I don't think that Lambda is going to make much of anything monetarily on the laptops. I think they're probably trying to get people familiar with the brand of Lambda, and hopefully they'll later buy like servers, right, from Lambda, or use Lambda Cloud. So anyways, those are my thoughts on the Tensorbook, and I think now finally we're at a point where there really is a deep learning capable laptop. It exists. And I look forward to the future of doing deep learning on laptops. I hope one day we really will have the ability to have something like an A6000 desktop version in a laptop. I think that would be really cool. So I look forward to seeing how things go. And hopefully NVIDIA will stop naming things the same as desktop GPUs if it does not match the specs of the desktop GPU. That's really frustrating. Anyways, questions, comments, concerns, suggestions, whatever, feel free to leave those below, and I will see you guys in another video. If you're interested in learning more about neural networks and how they work, then you might want to check out Neural Networks from Scratch, a book by myself and Daniel Kukiewa, inside of which you'll learn how to code neurons' activation functions, how to calculate loss, do optimization and backpropagation, and of course apply everything that you've just learned to a problem. The book itself is in full color for graphs and code syntax highlighting. Everything's on high quality pages with full font and a comfortable line spacing to make reading easy. Finally, every concept, including the math and coding, is broken down into the truly atomic parts and then put back together step by step to give a full understanding of neural networks and how they work, including all of the math behind them. By the end of the book, you will have created your own neural network framework from scratch. This is the book that I wish existed when I was learning deep learning, and I'm extremely happy to be able to offer it to you. If this sounds interesting to you, then you can head over to nnfs.io to learn more and buy yourself a copy.